there are 4 examples to go to finish 1.4. So we just got started, but I'm going to go through the examples 2 and 3 pretty fast and really concentrate a bit more on 4 and 5, the multi-step problems. So example 4 essentially is telling yourself, is something a solution to a problem or not? And the words that that book uses are check whether, and the number they're giving here, 3, is a solution. And I'm not going to write the whole thing out, but to either an equality or an inequality. In other words, if it's a solution, the equality is a true statement, or the inequality makes a true statement. Let me go through that. Once I've done one, it's going to be totally obvious to you what I mean. 8 minus 2x equals 2. And they're asking, is 3 a solution? What they mean is, if I plug in 3 for x in this case, right? If I put in 3 right here, if it's a solution, this statement should be true, right? So if I make 8 minus 2, and I put the 3 in right there, eight minus 6 equals 2. Is that a true statement? Well, yes, it is a true statement. 8 minus 6 is 2, right? If that is true, then 3 is a solution. If I had used another number, say I had used, let's see, 2, right? Well, then you would work it out, see that 8 minus 4 is not 2, and you say that's false, right? 2 is not a solution. But because we use 3, it is. So I'm not going to go through all the examples, but I am going to go through one with an inequality, so we can look at that as well. If I have 2x plus 5 is greater than 12, and I want to find out again, is 3 a solution? Now, I know for those of you who are watching that the book uses z instead of x, which my z's aren't great, so I avoid them. So I'm going to plug in 3 for x. Is 2 times 3 plus 5 greater than 12? 2 times 3 is 6. 6 plus 5 greater than 12. Is 11 greater than 12? No, it is absolutely not, right? So this gives you a false statement. In other words, so 3 is not a solution. Okay, so that's that type of example, and you'll have a couple to practice with. Oops, this should have been 2, not 4. I bet some of you are laughing at me quietly. Let's look at 3. Now 3 is just playing with mental math, and some of you love that and some of you don't. But this is mental math with a different kind of a purpose. Just like we were taking words earlier and making words into numbers or equations with numbers and operators like plus or minus or division and equal signs and inequality signs, we are going to do the reverse, and we're going to go with numbers and variables and algebraic expressions, equalities and inequalities, and do the reverse and put them into words, because we have to get fluid with what we're saying to ourselves in our head to get good at this algebra stuff. So here, what you need to be saying in your head is, and you've probably done this before, by the way, what number plus 4 equals 10? Now, I suspect it's a little bit like reading. You automatically looked at this, right? And you saw 6 because, right, you've practiced this kind of thing before. But we're going to do things a little more complex, and that's one of the reasons we practice some of this. Let's try a different one. Let's see, 6n equals 42. What are you going to say to yourself in your mind? 6 times what? Or what number? Say 6 times what equals 42, or what number, right, is 42? Well, I'm sure, again, you looked at that and probably barely blinked and came out with 7, right? That's why we've been doing speed drills, so that you get good at that. All right, so that is just a couple of examples we're going to have a little practice with before we get to what I call the good stuff, right? Some of the harder material. All right. Going on to example 4, finally 4. And that's the first of the word problems. And it is a multi-step problem. So we'll start. The last time, you and 3 friends. So you and 3 friends went to a mountain bike park. You had a coupon for $10 off and paid $17 for 4 tickets. What is the regular price of 4 tickets? Okay. Okay. So you and 2 friends, this is bothering me. Here we go. You and 3 friends, pardon me, are going mountain biking. And you have coupons for $10 off. And when you're done and you've paid, you only had to pay $17 for all 4 tickets. Right? What's the regular price for the 4 tickets? So you need to set this up, right, as a verbal model. In other words, you need to be thinking in your head, regular price, right, that I would pay for 4 tickets. For 4 tickets for all 4. Minus my coupon equaled $17. This is what I paid. I paid $17 after my coupon. So after I handed them the coupon, I paid $17. Right? So my regular price minus that $10 coupon gave me $17. Well, as an equation, we'll call this P. I have to name it something, and this is where you end up with a variable. P, my regular price for 4 tickets for all 4, minus $10 is 17. So I find that my price P therefore has to be, right, $27, because for me to have subtracted out $10 and paid only 17, that means the price for 4 tickets had to be 27. That's where the mental math came from. Now, that's for all 4 tickets, right? Then they do ask a second question. I didn't write at the top yet. If you pay the regular price this time, next time, right, and you don't have a coupon, and you pay equally, right, how much does each person pay, right? So if you're going a second time, right, how much does each person pay? Actually, I should have labeled this step 2. So now step 3, this time, unfortunately, I don't have my coupon, right? So I have to take my $27 and think, okay, well, that, if I divide that by 4 people, that's going to cost us each $6.75 per person. So we know that's how much we have to bring to the park this time, because no coupon. Okay, so first of all, you have to have a verbal model. In other words, a verbal model is what you say to yourself in your head. It does help to write it down. Sometimes when I write it down, I draw a picture. I did not do that this time, but this is my way of representing it, okay? I know that I'm handing the guy, right, $17 plus a $10 coupon. So the regular price would have had to be $27 because that regular price minus the coupon came down to $17. Therefore, this time I'm going and I need to know how much each person has to bring. Well, we figured out that for 4 people that was 27, which meant if I divide by 4, it's $6.75 per person. Okay. Example 5. Again, we have to think through what they're saying. This time we're talking about basketball. A basketball player scored 351 points last year. If the player plays 18 games this year, it doesn't tell you, by the way, how many games he played last year. If he plays 18 games this year, will an average 20 points per game be enough to beat last year's total? Okay, imagine this. This guy, he had a really great year last year. He scored 351 points. He's starting this year, right? He's got 18 games to play. And he wants to beat it. Of course, I would want to beat it, right? So this is going to be, first of all, you need to think to beat last year's total. Last year's total was 351 points, right? If you want to beat it, what am I going to put in front? An equal sign, a less than sign, or a greater than sign? Or a greater than or equal sign? Does he want to get equal 351 points? No, he wants to go more than 351 points. So whatever it is has to be greater than 351 points, right? So this is points, this is last year's. He wants to beat it. And we've got games this year. This year. He has 18 games to do this in. Okay? And we don't know, right? How P is the average points per game. Right? Average points per game times 18. We want that, right? 18 times whatever P is to be greater than 351. Okay? So let's try 20. Will 20 help him beat his score? If we put 20 in for P, right? If he does an average 20 points per game, is that going to help him beat that score? So step 1 is setting up your equation or inequality. Words and numbers. Step 2 is just try it. So is 18 times 20, is that greater than 351? Is 20 a solution? Does it make a true statement? Right? We created a statement from the words. Does this make a true statement? Well, 18 times 20 is going to give you 360. Is 360 greater than 351? Yes, indeed. And so if this year he knows I've got to average 20 points per game, I can beat my last year's points. All right, that is the end of this lesson. Part of your homework, I would like you to do guided practice. Let's see. 3, 6, and 4. And sorry, and I'm not counting, and 8. 3, 6, and 8 to hand in with the rest. Have a good evening or day.